Okay, the top is just, it's actually a rule you already have written down from yesterday because I reminded you that the natural log of E was what? 1.
Oh.
Remember that?
Yep.
So this is just telling you that the integral means the area, correct? So the area is 1 over t dt, which is 1. It's just telling you that the natural log of E is what? 1. And the natural log of e to the x is what?
0.
X.
Oh, that's what I meant.
And these two rules are the same rule? Because what's the exponent on the first one? 1. Okay, that is just it's just an explanation of the rule that you already know. Okay? Clear?
Yes.
It's an explanation of why it is, I guess. Okay, so now we need the rule for derivative of a logarithm. Now, I'm going to give you 2 rules, but you only should remember 1. Because if you look at them and listen to me, it's exactly like this up here. When I said, here's 1 rule, here's another rule, but which rule do we remember?
The bottom.
The bottom one, because it goes for everything, right? Okay, so it says dx of the natural log of x is 1 over x. And x can't equal, actually, x has to be greater than 0 because of the domain. First of all, it can't be 0 because it's in the denominator, and it just has to be greater than 0 because that's the logarithm domain. Yes?
Yes.
Okay. So now this is the rule you should know, though. Derivative of the natural log of u, meaning whatever is in the natural log, is 1 over u times du dx. In other words, the derivative of a u over u. And u has to be greater than 0 because that is the domain of natural log.
So don't write down that middle little piece.
No,
Skip
because du of dx means what? U prime?
that. Yeah. And the comma, that means, or the apostrophe, so it's just u prime over u.
U prime over u. And yeah, that
U is greater.
The comma is
this comma is in a bad spot. That's out of the textbook. There. Is that better?
Yeah, that makes me feel better.
Use some concealer. Skin tone was white. Okay. U prime over u. That is the rule you remember. Why would I waste my time with the first one? Because I just wouldn't. Kel, can you get your foot off the stool? That's really not... Another one broke, so that's why I'm going to be...
Oh, who broke it?
I don't know. It won't stay up. It won't stay elevated now. Okay. So, again, you have to identify u. Yes?
Yeah.
So, d dx, which just means the derivative, correct? Okay. d dx of the natural log of 2x. I would highly suggest putting what you're taking the natural log in parentheses. I've always suggested that. The book doesn't always do that. If you don't do that, you might get confused. So, u is what?
U is 2x.
2x.
2x, not 2 of x.
So, u prime
Is 2.
is 2. So, it's u prime over u. So, it's 2 over 2x, which is 1 over x. Okay, so now I have d dx of the natural log of x squared plus 1. So basically, we're just going to do a bunch of examples.
Okay, well, I can handle that.
So the first thing I need to do is identify
The u and
u.
non-u.
And if you have a derivative in a roll sheet, I would highly suggest you put this on there.
Imagine having one
But if you don't, I guess you don't. Okay, so what's u?
of 2x. Or x squared plus
Well,
1.
now you must
X
make
squared
this
plus
I
1.
wrote
Because
2x.
I was just ripping ahead.
So u prime is
2x.
2x. So the derivative is
Or x squared plus 1.
okay, so now I have d dx of x times the natural log of x. So So what rule do I have to use?
Product rule?
I have to use the product rule because it's x times the natural log of x, right? So the product rule is,
The product rule is, it would be like x plus, no, it'd be like f but plus g prime minus plus. Give me a second, I can tell you.
how about, I like to do the first one.
Don't say it, just let her find it.
But I have it right here. Which one?
Because she has a sheet.
I do have a sheet.
Okay, but I can just say it.
Okay, wait, no, I'm gonna say it. The product rule is f of x times g prime of x plus g of x times f prime of x.
Okay, so the derivative, and I like to do the derivative of the first times the second. You guys do it that way? I do it the same way I do the quotient rule.
I don't know how to do either one.
Okay.
That's impressive that you've been in this class for this long and don't know how to do that.
Okay, so the derivative of x is 1.
Is 1.
So 1 times the natural log of x plus x times the derivative of the natural log of x, which, if you remember the first rule, is just what?
What? Sorry?
The derivative of the natural log of x is just 1 over x,
Yeah.
because u is x and du is,
Sure.
no, right here. So u is x, u prime would be 1.
Yeah, that's right there. I'm sorry.
Okay, so I get, it looks like this would be 1, right? And I like to put the 1 in front. So 1 plus the natural log of x. The book would have this, and I don't like it. They would write it exactly like this. And that, to me,
Linux plus
that's a lot of gaps.
Linux operating software.
They would have this. And my brain would be like, what are you taking the natural log of?
I would do that too.
I don't know why they don't use parentheses.
I don't know. It's not like they're saving a lot of ink by not using parentheses.
Well, they use it randomly.
Yeah. So, I mean, if you're going to write it like this, I use the parentheses all the time anyway. But the book does not. And I do not know why. And I hate when they do the trig functions and don't use parentheses.
I hate when I do this.
Okay, ready for another one?
No. Are we signing up for that soon?
I sent you the email. I assumed you signed up for it already.
When? Did you send it?
Last week, 2
Yeah,
weeks.
It might have been 2 weeks ago.
How do you sign up for it?
You go to your email.
You go to the email and follow the directions.
Is it too late?
No. February 10th is too late.
Oh, okay, good. I'll do that later.
Okay.
I'm glad I saw that and asked.
Okay, d dx of the natural log of x cubed. Okay. So what rule am I going to use with this one?
The chain rule.
The chain rule. Good
At
job.
least you can recognize it. You just can't do it.
I can recognize it.
Okay. So I do the chain rule by taking the derivative of the outside function times the derivative of the inside function. Yes?
Yeah.
Okay. So the outside function is the cube.
Yeah.
So it'd be 3 times the natural log of x times, now what's the derivative of the natural log of x?
1 over x.
1 over x. So I personally would write this as 3 over x natural log of x.
Of course, you person.
Or you could write it 3 natural log of x all over what?
X.
X. And I think the book writes it really funny, if I'm not mistaken.
I feel like the book writes most
Oh, what did I forget? What did we forget when we did this? We forgot the
squared.
squared. I probably said it and forgot it. The book writes it as 3 natural log of x squared. That is horrible too.
Yeah, I did think that was 1 for 2.
Squared 1 over x. Like exactly like that.
Okay, well, I don't want to look at that ever.
That is disgusting.
Are those all supposed to be saying
Yeah, they all do. Well, this doesn't. Well, I guess it does.
Yeah.
They all say the
Same
same
as
thing.
odd.
Where'd that squared come from?
The chain rule?
The chain rule.
Yeah.
I loved the disgust on Autumn's face when I wrote this. That is horrible. Like, why would you ever write it like that? And that 1 over x is like so close. It's even closer than that. Okay.
And you don't know what you're writing.
So now what?
Now we go to the next one.
Yep.
The new problem?
Now I write it down.
Uh-huh.
That's all I have to do is leave it like that and I win?
So we have
d
chain
dx.
inside of the natural log. So we have to find the root of that and use the u prime over u.
I would do the natural log of x plus 1 to the what?
1/2.
Okay, now wait, guys.
Okay.
That is not the chain rule.
Okay.
Because what's the difference between this?
That has
Well,
an
is
outside
that-
function.
And that.
It doesn't.
Because you'd have to find the root of u still.
There's no
Why is
outside
blading here
function.
calling me?
We're going to have to find the u, yes.
Yeah.
But there's a difference between these two, isn't there?
Yeah.
So the natural log is the inside function here, isn't it?
Yeah.
But it's not over here.
Yeah, we don't have to
What do
change
we do
that.
with exponents when we have exponents with natural logs?
I don't know.
They become the answer.
Don't they go in front?
Oh yeah, I forgot.
So we're going to have
I just forgot.
d dx of 1/2 times the natural log of x plus 1. So does that make my problem even easier? You two need to focus.
I thought it was next week.
So now that I've moved the 1/2 out in front, I just have a normal problem, right? So, Natalie, stop. U is what? X plus 1. U prime is 1. So my answer is just going to be 1/2 times 1 over x plus 1, which would look better as 1 over 2 times x plus 1. Here's the rule of thumb. You leave it how you would like to plug a number into it. Does that make sense? So on this other one where I had 4 different choices, this would be the choice that I would like to plug it into. So that's how I would leave it. Ready for another one? You good, Cal?
Yeah.
Okay. d dx of the natural log of x times x squared plus 1 quantity squared over the square root of the quantity 3x cubed minus 1.
No, it's 2x cubed minus 1.
Oh, 2x cubed minus 1. What did I say? 3?
3.
So that looks like a lot, doesn't it?
Looks like we should skip it.
Okay. Do we have something that could make this go easier?
I'm sure we do.
Could we rewrite the natural logarithm so it wasn't so condensed?
We could expand.
That was a hint. We could what, Kale?
How far do we want to expand?
We could expand it. We want to expand it all the way. If we're going to do it, we're going to do it all the way.
Okay,
So this is why you did yesterday's assignment. So we have d dx of, well, up here it's going to be plus, right? So it's going to be plus right here. So I'm going to have the natural log of x plus 2. Where's the 2 coming from?
the exponent.
The natural log of x squared plus 1.
Minus 1/2. 1/2 natural log of 2x cubed minus 1.
minus 1/2. Where'd the 1/2 come from?
Squared.
The square root times natural log of 2x cubed minus 1. I was going to say 3 again. Now, is that going to be easier to take the derivative of? Yeah.
Easier.
We're just going to take the derivative how many times?
3.
3 times, and we're going to add and subtract it. So the derivative of the natural log of x is 1 over x plus 2. And the next one, u, is,
X squared plus 1.
and u prime is,
2x.
so it's 2 times 2x over x squared plus 1 minus 1/2, and u is 2x cubed minus 1, and u prime is 6x squared. So then 1/2 times, and then I simplify. So I would have 1 over x plus 4x over x squared plus 1. Oops, I was going to put minus. I'm just going to put plus. Minus 3x squared over 2x cubed minus 1. And you could get common denominators, but you're not even like close on those. I mean, you can, but I think that would make it worse to deal with.
Wait just a second.
Yes.
Why did that one become 3x squared?
That's half of 6.
But why didn't you do anything at the bottom then?
How does multiplication work?
The reciprocal.
You're reducing. Like, this is 6x squared over 2 times 2x cubed minus 1.
Yeah.
So by using our expansion that we practiced yesterday, will it make our derivative much easier?
Yes.
Can you, I mean, because without that, in order to find u, like u is the whole middle, right? In order to find u prime, you would have to use a product chain quotient to find the derivative of that.
So
Would that be fun? No. And that's in the numerator. So then you'd have to multiply by the reciprocal of the denominator. I don't want to do that.
So what you're saying is all the chain ones I can just expand?
Well, but
No. No, Natalie.
Can't die. You can do that.
This has this nice little what right here. And that gives me a whole bunch of rules I can use. And if I know them, it can make my life easier.
But the issue with the chain rule one was that the natural log was cubed, not just the function with cube.
She's talking in general. With no natural logs involved, can she use natural log rules? Not unless you want to take the natural log of the left side of the equation also. And then that brings in all those rules, which we are going to do in a minute. Anyway. Okay. We good?
I thought we were done.
Oh, no. Okay. Find the derivative. Well, maybe that's why I'm here. I don't know. I could be wrong. Okay, so we have y equals
Yep, we do.
x minus 2 quantity squared over the square root of x squared plus 1. So Natalie looks at this and says, I see a chain quotient and I don't want to do it. So she said I could just expand it. Well, you can, but what's missing?
The natural log.
So I have to take what of both sides?
The natural. The
Click
natural
to
log.
add title.
Yeah.
Where did it go?
I
Oh,
don't know.
wait.
There it went. I touched it with my hand and it freaked out. Okay, so as long as I take the natural log of both sides, this is legal, correct?
It's legal, we're not gonna get arrested.
Not going to get put in math jail. So I'm going to have the natural log of y equals the natural log of x minus 2 quantity squared over, I'm just putting x squared plus 2 to the 1/2. How about you guys?
Yeah.
Okay. Now what can I do now?
Now you can expand.
Now I can expand that right hand side because Natalie says she wants to do this instead of the chain rule. So we have the natural log of y equals 2 natural log of x minus 2 minus 1/2 the natural log of x squared plus 1. Did I do that right?
Yeah.
Okay. So I still haven't taken the derivative like it told me to.
No, you haven't.
So now that I have put the natural log on the left, I have to differentiate the right and the left.
Just one. One equals.
So I have to do,
1 equals.
I can't fit my dy. Okay, so u is y, correct?
Yeah.
And then derivative would be y prime. So I have y prime over y equals,
And then just put it-
then I just go through, right? So 2, and u is x minus 2, so u prime would be 1. So I get 1 over x minus 2. Ooh, I should put y prime on top, huh? Minus 1/2. U is x squared plus 1. So u prime
Just 2x.
is 2x. So I have 2x over x squared plus 1. Yes? And I'm still supposed to find the derivative. But on the left-hand side, I have an extra what?
Y.
I have an extra y, so I need to
Multiply the entire right side by y.
multiply the entire right side by y. So I now have y 2 over x minus 2 minus 2's reduce
Over x squared plus 1.
over x squared plus 1. Now, I'd probably find common denominators here just because I have lots of pieces. So, well, first of all, I can't leave x's and y's in the derivative, can I?
Apparently not.
No, that's illegal. It's not right.
So we are going to math jail.
So, what's y equal?
We don't know.
Yes, we do.
X minus 2 squared over.
It equals that, doesn't it? Okay, so we have x minus 2 squared over x squared plus 1 to the 1/2 times. Now over here, we're going to have to multiply 2 by this and x by this, correct? Okay. So then I would have 2x squared plus 2 minus x squared plus 2x all over x minus 2 times x squared plus 1. And I think we need to make this look a little prettier, don't you?
Yeah, I think I've left plenty of y's in the derivative.
No, you should not have, ever.
Yeah, because like y prime equals 2xy.
No, because then we had to go back and plug in y. Yes. Anyway, you cannot do that. So let's make it prettier. What can we do? You have an x minus, I have two x minus 2's in the numerator and 1 in the denominator, so I can reduce out 1, right? Okay. Well, so what does that make my denominator now? X squared plus 1 to the what? To the 3 halves. And where'd you get 3 halves? We got 1 here. And Kale, focus. You are distracting, not paying attention. Okay. And then we have what? X squared plus 2x plus 2, right? Is y prime.
Should we say like
Where
2.5?
did the x minus 2 go from?
Oh, I forgot it. Thank you. Times x minus 2. Thank you.
Aren't we going to distribute that too?
No.
Did everything else?
No, we didn't. The only reason we distributed it is to get those together because we had some hanging out in both.
Just left the y.
So, could we have done the quotient and inside the quotient, the chain, twice and got the same answer?
Probably not.
Well, we should have gotten the same answer, but actually by doing this, did it help us not have to do all of that? Yes.
Yes, it did.
So, Natalie, the answer to your question is sometimes you could do this and not have to do the chain.
All the time.
Okay. You try it.
I will.
Okay. Absolute values, we need to think about them a little bit. It's really not overly difficult. Here's your rule. Okay. If u is differentiable function such that u does not equal 0, then the natural log of the absolute value of u is u prime over u. So I have find the derivative of f of x equals the natural log of the cosine of x.
Isn't that the same thing?
So what's u?
Cosine of x.
Cosine of x. And what is u prime?
Sine.
Nope.
Negative sine.
Negative sine of x. So it is negative sine of x over cosine of x, which is
Negative tangent.
negative tangent of x. If we can change it into sine, cosine, or tangent, should we always do that? Yes. Okay, what if I asked you to find the relative extrema of a natural log function? Extrema is a min or max, yes? How do I find a min or max?
Derivatives.
The first derivative and set it equal to 0. So if I ask you to find the extrema, which are what?
Relative.
Min and maxes of y equals the natural log of x squared plus 2x plus 3. What do I have to do? Find the derivative. So u equals x squared plus 2x plus 3. Hopefully after today you won't have to write all those out. And u prime equals 2x plus 2. So y prime equals 2x plus 2 over x squared plus 2x plus 3. Then I have to set it equal to 0. But when I set it equal to 0, what is going to happen to the denominator every single time?
Cancel out.
It's going to 0 out. And so I really just have 2x plus 2 equals 0. So 2x equals negative 2. So x equals negative 2, or negative 1. So x equals negative 1. So if I ask you for the point, how would you find the y? You plug it in, right? So I would have the natural log of 1 minus 2 plus 3, which would be the natural log of 2. So, is it a min or max?
Miniature.
A what?
Min.
Min. Did you say miniature?
Yeah.
It's a min because this equation would open up, correct?
Yeah, that's what.
Why would this equation open up? Because it's a parabola and it's positive and it's opening up. It's not going to look like a parabola, but it's going to have that same shape. That's all I got from you today.
That's all.
That's all.